Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is a lock synchronization primitive. Before proceeding, make sure that you have already watched these other videos first. The mutually exclusive execution property of a critical section is provided by a lock synchronization primitive. A lock synchronization primitive is a variable whose data type is called mutex. If thread A calls this lock function at a time when thread B is in the middle of the critical section, then thread A will get blocked, which means it will be forced to wait until that lock variable gets unlocked. In a situation where this lock function would have blocked, you could call try lock, which immediately returns false instead of blocking. A software system may involve multiple locks for multiple atomic actions. Also, a single lock may protect several different fragments of source code, in which case you should think of them as collectively being one atom. The lock maintains a record of which thread called its lock function. That thread is its owner thread. And only that owner thread is allowed to call the unlock function. Unlike the way Win32's version of multithreading works, that owner thread may not nest another call to lock. It needs to call the unlock function before it can call lock again. Replacing the call to the lock function by using this oLockOnce object is kind of like using a smart pointer. When this oLockOnce object goes out of scope, that oLockOnce object will automatically call the unlock function for you. This unique lock template is like the lock guard template that we just saw. This unique lock template is also kind of like a smart pointer in that it calls unlock for you when this object goes out of scope. What unique lock allows you to do is, while it's still in scope, you can unlock the synchronization for a period of time and then relock it later. In fact, you might cycle this unlock relock as many times as you need. If this smart pointer-ish object goes out of scope while it's unlocked, then nothing happens. It doesn't unnecessarily call the unlock function. If you want to query whether it's currently in a locked or unlocked state, either cast the object to a Boolean or else call ownsLock. You can use move semantics to move a sign between two unique lock object variables. If the destination object had been locked, then it will automatically get unlocked prior to being overwritten. By default, creation of the unique lock object causes a call to the lock function on the underlying lock synchronization primitive. However, that can be skipped by specifying this defer lock parameter. Some deadlock avoidance techniques take advantage of this ability if they need to simultaneously lock two locks.